In terms of the two main types of waves, they have similar properties. And again, once you understand one type of wave, it applies to any wave. So in terms of the basic properties of waves, there are two main types of waves that we can define. The first one is called a transverse wave. A transverse wave, simply by definition, is the particles of the medium vibrate perpendicular to the direction of travel. So notice here on the string, in slow motion here, this is really cool. The wave goes, let's say, front and back across the room here. But the particles of the string actually vibrate up and down. So notice that even though the wave travels front to back, the particles go perpendicular up and down to the direction of travel. In some ways, a simple string being snapped up and down is a way to visualize that. Now contrast that to a longitudinal wave. By definition, a longitudinal wave is a mechanical wave in which the particles vibrate, instead of perpendicular, parallel to the disturbance. So notice the wave travels left to right here, and the particles also vibrate left to right. Sound is a good example of a longitudinal wave. Why is that helpful to know? Well, in real life, if you know how a wave is behaving, you can design things for that purpose. So for example, for sound waves, it's useful to know that it's a longitudinal disturbance. If you're designing a musical instrument and you want to tune it right, or you're trying to build a concert hall and not have too many echoes, etc. Finally, some basic wave characteristics. We call the resting point, where the wave is just sitting there, the equilibrium line. So this could be like the string just sitting there still, or an ocean wave just sitting still and there's no disturbance. Once you put energy into the wave, then you can generate a high point called a crest, a low point called a trough. The distance it takes a wave to repeat itself is called the wavelength. And the symbol we use, we run out of letters in the English alphabet, so it's the Greek letter lambda. It looks like an upside down Y, is a symbol we use for wavelength. So notice I could go crest to crest, would be one wavelength. I could also do trough to trough. Or if you think of your math class, I could pick a sine wave where I go from 0 point to 0 point. So think of it like a roller coaster. Once you repeat yourself, the ride is repeating itself. That's a wavelength. The amplitude is a maximum distance from equilibrium, and it's a measure of the wave's energy. So obviously, if you're surfing, you try to hit big waves, like in Maui. So the amplitude is a way to measure the wave's energy. Now we can